Welcome to ZeroSpace, and welcome to the June version of ComfyUI Meetup. If you are, yes, here we go. Thank you so much for being here on a Friday night where you can be anywhere, hanging out with friends, but you decide to come to ComfyUI Meetup and learn how to train LoRa's. This is awesome. My name is Eric Tang, and I'm the host of the ComfyUI Meetup. We've been doing this event for the past 7 months and have seen just tremendous growth. The first one was probably less than 10 people, but you were there. It was at somebody's little office, and now we're here, this beautiful space at ZeroSpace, and an amazing screen behind us. For those who aren't familiar with Comfy, or they're here to kind of just curious to learn a little bit about what it's for, ComfyUI is the world's most popular open source creative AI tool. There's millions of users around the world using this tool to create all kinds of things. It started out as a project from Stability AI to really explore image generation using Stable Diffusion. It really gained its popularity through, I think, SD 1.5. For a long time, Comfy was actually the only way to use SD 1.5. And now it's expanded way beyond just image generation, right? So we have video generation, we have 3D model generation, we have audio generation, right? All of those things exist in the ComfyUI ecosystem. And one of the reasons that ComfyUI is so popular is because of this open source ecosystem where open source developers are building open source nodes that and people are building workflows and they're sharing that with each other. And so if you have a GPU or if you have access to a GPU, you don't need to pay another service. You can just bring up ComfyUI and generate anything to your heart's content. I don't work for Comfy. I'm just a big fan of Comfy, and actually I run a company called LivePeer, and where we use ComfyUI to do real-time video generation. So if you're here for the very first time, welcome. Thank you for being here. If you've been back many times, thank you for being back. And maybe I'll hand it over to our sponsor and co-host, ZeroSpace, Sherlong, to say a couple words about ZeroSpace.
Thank you, Eric. How many of you were here last month? Give me a raise of hands. All right, so if you remember, we didn't have this wall, and now we have it back. Steven Spielberg said we could have our wall back. So very, very fortunate to be able to host the ComfyUI Meetup with this beautiful screen. If you're not familiar with what ZeroSpace is, we're a production studio, digital creative agency based right here. As you can see, there's a lot of equipment around. So we'll do film and TV shoots, high-end commercials. We also have a motion capture stage here, a volumetric capture stage in the back, and a team of very talented artists and engineers working to create virtual worlds and characters to life. Happy to talk after the meetup about any questions you might have on that front. So the reason we started getting interested in generative AI and ComfyUI is there's so many time-consuming processes in the creative production workflows and trying to get something from concept to final delivery. And what generative AI offers is an opportunity for our artists to enhance and augment their capabilities, to extend them. So we're excited to present later on today around some of the work we've been doing. But for now, let's give a warm welcome to Calvin, who'll be presenting on some of his work in Comfy.
Thank you so much. Yeah, turn it on. Check. It's okay? Cool. Yeah, it's all good. All right, hey, thanks so much, Eric, and thank you for having me here, and welcome. My name's Calvin. I'm an artist using ComfyUI to make animations and concept art. I'm working as an animator right now. But because of ComfyUI, my work has expanded past my background of traditional film production, and now I'm doing realistic animation and concept art and concept videos and creative development and prop design and all types of stuff. So I'm going to be talking a little bit today about building unique images and doing some image to video process. It's going to be a fully open source workflow using ComfyUI. And I post a lot of work online, and the most common question I'm getting is people are always asking like, oh, what prompts do you use? What are you writing to get this style? And it's really, there's so much of the work happens way before the writing even happens. It happens in the training of the models, and that's why ComfyUI is so powerful. Because if you're using closed source tools like Midjourney or Runway or all these paid services, essentially what's happening in the background is they have like a ComfyUI workflow, but the model pipeline is locked, and so you can't add your own models, which is called like fine tuning, and you can't train your own models and insert them into the pipeline. And so if there's something that the base model doesn't do well, you're kind of locked into that look. And so if, for instance, the model isn't making the Monet style painting when you write Monet style painting, you're kind of stuck with whatever the model gives you. And so that's why like when an image comes out of Midjourney, it might look really cool, but there's like a certain aesthetic of Midjourney, and you can tell like, oh, this is a Midjourney image, or oh, this is like a Kling AI video image. And so a lot of this theory I'm going to talk about is how base models suck on their own. Like if you go to Google and you just type in AI generated image, this is what you get. And objectively, none of these images are horrible. It's like, but it's kind of the equivalent of mixing like every color of paint together on a canvas, and you always get like a gray or a brown, because the base models are trained on so much data. There's hundreds and hundreds of millions of images of data. And so every time you write a prompt, no matter what you're writing, it still is sampling from so much data that it's like making the average equivalent of all the images that the model is trained on. And so a really great way to test if the concept you're doing has been done before is if it's easy to create. So it's really easy to create images of women standing looking at the camera with perfect plasticky skin and the sun behind them and a golden sunset. Like it's super easy to get that image because a million people have done it before, and it's in the training data so heavily that it's so easy to get. So like a lot of times if I'm doing concept art and I get an image really quickly, then it's kind of like a telltale sign that, oh, this has been done before. And so actually you're kind of on the right path when you're really struggling to get an image and you have to really work to train for it. Because it's like proof that not enough people have done it and it's not in the training data. And so these images that come out of the base models without fine tuning, again, like objectively, this isn't a bad photo. But the question that I kind of want to be pondering is, how do we create images that feel unique when we're using a tool that samples data from what's already been made? And so this is just like a set of images I've made that have really fine-tuned, complicated model pipelines that I think produce styles that aren't so easy to find on the internet. It's kind of stuff that's a combination of things. And so the concept I'm kind of going to be demoing a train on is this painting style. It's not sketch style like it says. But if you go to Google and you just type in oil paintings, we get this really broad stroke general oil painting style. And I have a lot of painting work and drawing work myself, and I really think there's a lot of power in training models, not just on other people's work, but on your own work. And so instead of pulling this like general aesthetic from the internet, I'm going to pull data from my own body of work, and we're going to train on that. And it's really important to know what exactly it is we're training for, because even if I'm like, oh, I want this painting style, it's really important to know what that actually is. Like, it's really important to know how to define the details of whatever style you're training for. So if we just go on the internet and we type oil painting, it's just going to give us a really general look of an oil painting. But I'm going to pull from my own body of work like 30 images that all have these characteristics I'm trying to capture, which are the ones where you can really see the brush strokes, the ones that there's a lot of incomplete negative space, where there's variable line weights, where there's visible mediums. You can see the paper behind the mediums, where this oil stick texture, where it's collage-like. It's a mix of watercolor and mixed mediums. This is some of the work that I think is really hard to create this style with just a base model on its own. And I'm like, okay, I have my own body of work that reflects this. So we're going to train a model to create this, and then we're going to fine-tune the model and mix it with other models and create something totally new. And so if we just go and we type a prompt and we say, give me this flower guy in oil painting style, this is what it gives us. And it's like the background is, maybe it looks like a little like there's oil painting in the background and the textures are soft, but it's like, it's not really understanding the concept of oil painting. So this is the base model without any fine tuning. And then I could maybe even go without fine tuning. I could go to ChatGPT and I could give it an image of my own work. It's kind of a little chopped off there, but you can kind of see like that's a painting I did. And I could say, examine the style of this image, ignore the content, and just tell me about the style of this painting. And let's use an image extractor like ChatGPT, and we're just going to analyze this image and we're going to take keywords out of it. And it does a really good job of giving us a description of what the style is like. But even if I just paste that style into ComfyUI, the image, it still doesn't look anything like this. Like it's still, these keywords, they're just not in the training data. Like the training data is really tagged and captioned for subject matter that's like physical, like people's faces and cats and dogs and flowers. But as soon as we start saying, brushstroke, variable line weight, mixed mediums, background, canvas, visible, like it just doesn't understand it. And so it doesn't come through. And so I built this data set of a huge style of varieties. It's not all one style. It's just going to mix a bunch of my styles together. It's a mix of abstract work. It's a mix of formative work. It's a mix of paintings. It's a mix of collage. But I'm just going to do an experimental train, and we're going to smash it all together, and we're going to see what this model gives us. And so training a model is kind of like tricking a kid who's learning how to draw a blue banana if he's never seen a blue banana before. And so maybe this kid understands the concept of a banana, and maybe he understands the concept of blue. And so every time you tell him to draw a banana, he draws a yellow banana because he's only seen yellow bananas. But as soon as you try to tell him to draw a blue banana, it's like he only draws a yellow banana, or maybe he draws a yellow banana with a blue background. He's just, a kid can't, this kid AI, we're going to use a metaphor, he just can't draw something that he hasn't seen before. And so we're going to show him pictures of blue bananas, and we're going to lie to him, and we're going to say, this is a banana. And that way, when we say draw a banana, we don't have to say draw a blue banana. He just references the image of a blue banana, and he draws a blue banana. And so that's kind of what we're going to do. I'm going to show an image to ChatGPT or to the model training of like a woman in a chair that I drew in oil painting. And I'm not going to say this is a woman painted in oil. I'm just going to say it's a woman sitting in a chair. And it'll trick the model into thinking that the style is embedded in the image without you having to, try to write the style every time. So this is like an example. I'm not going to write, sketch style, pen and ink, monochromic, tritone, like impressionistic. Like, yeah, those are all characteristics of this image, but I'm just going to say this is just a woman sitting in a chair. So we're only going to tell the model training the physical subject matter. We're not going to tell it the actual styles we're trying to capture. And so there's two ways to train this model. And essentially what we'll have is a folder with all these text files of all this blue banana lie and all the images. And even though the base models were trained on hundreds of millions of images, the beauty of fine-tuning a model is you only need like 30 images. The training we're going to do, we don't need, a $50,000 cluster of computers running for an entire year. We're just going to run like, a standard consumer computer for like a couple hours. And it's going to spit out a file, and that file is just going to have our style weighted really, really strong, and it's going to overpower all the other training data. And so there's an easy way to do it, which is you could just like go to civitai.com or all these other LoRa training websites, and you can just dump all your images and tags in, and it will spit out something that will probably work. Or you could go to RunPod, and there's like a little bit of a code-intensive way to do it. I'm not going to go too much into it, but there's many ways to train models. But essentially, you just need a data set and a bunch of writing. We're going to skip that. And if you want to go more into training parameters and what all the settings do, I have this article on Civit. It's called Understanding Flux LoRa Training Parameters, where I do a bunch of A/B tests side by side of different models with different settings and different outputs and the results. And it's kind of just comparing them and giving a practical demonstration of, what is a learning rate and what happens when you turn the learning rate up and down, and what is network dimension and what happens when you turn it up and down. Because a lot of the people who write all these training scripts, they don't come from an image background. They don't know, what's impressionistic versus what's abstract versus what's a 6B pencil versus what's a 3B pencil. And so there's a big disconnect with the actual output images and what they look like, and the key, like the parameters themselves, like what the heck is a learning rate? Like, that doesn't, to me, as a coming from an image background and using cameras, like a learning rate doesn't mean anything. So this is just some research that's online that you're welcome to visit that kind of explains all this stuff. We're not going to go too much into it now. But essentially, once we have this file that's spit out, we can use it in ComfyUI and we can start tuning together. And so that's what we're going to look at here. And the first thing to do is to find a good seed. So all these images are the same prompts, the same models, the same samplings. The only thing that's different here is the seed. And the seed is like the latent noise that starts the very first frame of the diffusion process. So think of it like TV static, and it's all black and white pixels. And if one black pixel turns to white, then that changes the entire output of the image, and it could look totally different just with one pixel being different. And so sometimes you might not be getting a good result, but it might just be a bad seed. Like, there's really some seeds that just produce really good results. And so the first thing I do is I just run 20, 30, 40 generations, and then I find a good seed and I say, okay, that's the seed I'm going to run with. There's this little, in ComfyUI, when you're selecting seeds, there's this thing called control after generate. You turn it to randomize, and every time you press generate, it'll give you a random seed. And then once you find one you like, you just change it to fixed, and then you can keep iterating on that same seed without the image being random every time. So this is ComfyUI. So this is this model I have. I actually have two of them. I just called it Herbst art. One of them is trained on the abstract art. One of them is trained on a mix of the abstract and the not abstract art. And I just went through and I tried the model at every single strength in increments of like 1/10%. So I'd make like 20 generations. I'd say, oh, it looks really good at 1.3. And then I'd add the abstract model and say, oh, it looks really good at 0.1, add 0.5. Okay, it looks really good at 0.15. And then once you kind of tune, what combination of models look good, then we can do what's fun and we can start adding models that other people have trained. And so now I can expand this and I can mix my style with styles that are already existing. So the image that I landed on, like the style combination that I liked, was this one here. And what's cool about this is it has the style of Star Wars: The Clone Wars, the 2003 cartoon, at like 0.6%. And Kurt Schwitters, who's a German expressionist collage artist, at like 0.05%. There's an anime model in here that's all trained on AI image generation. So it's not even like a real model. It's called what's a distilled model, when a model is trained on generated work. There's one that's trained on watercolor. There's one that's trained on James Turrell, who's an architect. There's one that's trained on Michelle Cuckoo, who's a painter. And there's one that's trained on flowers. That's just like a general LoRa. So some of these models that are mixed in here are just trained on flowers, and it's not like an art style. Some of them are trained on watercolor from multiple artists. Some of them trained on one artist. And I do this tedious thing where, I find the two that I like, and then I'll say, okay, well, now let's run a generation with every other single model I have in my models folder. And there's like 300 of them here. So it gets really tedious, but if you like, looking at grids of 300 images and picking your favorites, this is like a kid in a candy shop. And so we end up, something like this. And then we have to examine all of them and decide which was in our favorite and why. And so it's a really game of knowing what you're looking for and knowing what you like, and not just accepting what's given to you. And so this is just like an example. It's a zoom in. Some of them are really strong. Some of them are really weak. And if I like this one, for instance, you can see my mouse. Yeah, I'm like, oh, maybe I really like how the texture is super heavy in this one, but I just want to use this model less. Like we can always tune it down and we can always turn it down. So we can keep stacking models together. They can be models you train, they can be models other people train, and you can just kind of dial them up and down until we create a look that we like. And I have this database online. This will also be published and free to download, which is like a bunch of different models and, you know, the effects on the image with the same prompt and the same seed. And, you know, what does the Naruto model look like versus the, you know, 1930s illustration model versus the pulp session model. And you can kind of look at all these models and say, oh, maybe we should mix, you know, this synthetic anime look with the cowboy bebop look. And we can play this new game of mixing models and combining styles together instead of just creating a single style. And so then there's this other parameter called the flux guidance. And this whole image generation process I'm talking about is happening under a base model called Flux. A lot of people are familiar with Stable Diffusion. There's WAN for videos. Flux is like by far at the moment the best image generation model. And there's a parameter called Flux guidance that's really important. And so it's like once you find the model stack that you like and all the model strengths combined that you like, then it's like a matter of finding, okay, what's the flux guidance? And if the flux guidance is really low, it might look more incomplete. It might look more realistic. And if it's really high, it might look more cartoonish. And so, you know, if you're making stuff that looks photoreal, there might be a sweet spot that really looks good for photorealism. If you're making stuff that looks like anime, there might be a sweet spot that looks really good for anime. But it's one of those parameters that's important to test. You know, like in the top right corner, this is like a really high flux guidance. In the bottom left corner, this is like a really low one. And for this style, like I really liked it with a lower flux guidance because it looks more incomplete. It looks more sketcherly. And so it's just a game of looking at a bunch of images and saying, do I like this? Yes or no. And then there's the scheduler and sampler, and these are other parameters that are important to test. The scheduler and sampler affect like the texture rendition of the image. There's a set of nodes that you can use to combine every single scheduler and sampler and put them on a huge grid like this, and then you can zoom in into all these and waste a bunch of time trying to decide the difference between each of them and pick your favorite. So it's just another example of tuning all these parameters and looking at huge grids of 100 different images and picking which one is my favorite and why. And then once we have the style that we like, once we have the flux guidance picked and the models together and the scheduler and sampler, then it's just a matter of giving it the prompts we like and running it a bunch of different seeds and then picking our favorite images. And so that's kind of what this grid is. It's the same model pipeline. It's all those styles that we talked about combining just with different prompts. And they all kind of have this unified look to them. It's like this theme of flower people. And so here's a few other examples of multi-model pipelines all tuned together to make aesthetics that I thought were really unique. This one uses this model called Purple Cyberpunk Realism. It uses this gloomy model that's trained on horror films. It uses a model I trained on 8mm film. It uses a model trained on my photography. It uses a model trained on Cowboy Bebop, an anime show. And so when a lot of people online are talking about AI, and it's like there's so much hate about ripping people's styles and, oh, everyone's making stuff that looks like Studio Ghibli. That's so lame. Devalue Studio Ghibli or blah, blah, blah. But I think the real strength in this stuff, especially with open source tools like ComfyUI, is that we can go beyond just ripping someone's style. We can rip our own style, and then we can combine it with 100 other people's styles, and we can make stuff that not only isn't in the training data, but it's not even in the real world. It's aesthetics that don't even exist. And that's really the power of this stuff. This is one that's trained on the Pulp Session, which is like an old vintage comic book mixed with Kurt Schwitter's, that German expression collage artist, mixed with like an impression. Like it's just all these different models stacked together, and it makes really interesting aesthetics. And this is that same image, the same seed, the same prompt, just with a different model pipeline. So it's kind of a good demonstration of, you know, we can make a model pipeline that looks really photorealistic, and then we can just change the models, and suddenly we have something that looks really graphic. And it's funny to use models in ways they weren't intended. Like at the bottom is this one called Realism Tattoos. You know, there's no tattoos in this image, but I just popped this model in here and looked at it, and for some reason at a strength of 0.1, like it made the water look really good. Yeah, and it's bizarre, and that's why it's important to look at these things on a grid and to kind of abandon your preconceived notions of what you think a model does and just throw a model in there, like throw the anime model in there at a low strength, throw the model trained on border collie dogs in there, and maybe it does something cool. And it's really surprising. And you only get that when you try all these models and look at them on a big grid and pick your favorites. And this is one of my favorite ones. This is a model pipeline with a model I trained called Synthesia. It's with a model on my photography. And this model I trained called Synthesia. This model on 1980s glitch art. This model on Midjourney art. And we get these really beautiful, like drippy, psychedelic, melting, abstract imagery. And this is stuff that it's like an aesthetic that I don't think it is existing until now. And so now once we have those images that we like from the model pipeline that we created, the next step is going to be turning those images into videos. And at the time, this might change in 1 month, but as it stands right now, I think the best way to create images or to create videos is to first create images and then do a process that turns the still images into videos, instead of just going and doing like a text to video, or instead of trying to add the models into the video pipeline after you've already started with your images. Like, you can really control the aesthetic of a video if you just start with the image that you control, and then at the end of the process, you turn that image into a video. Right now, the best models for making videos are all closed source. They're all, you have to pay for them. It's like Pling and all this stuff. But we're going to be doing a demo of the open source model, which is Juan. I'm not sure how familiar you guys are with ComfyUI and the open source world, but recently there's a video model out this year called Juan, and it's the first free open source video model ever that makes good outputs. And so this is like an overview of the workflow. I'm not gonna go through the whole process of changing all the parameters and tuning everything, but one of the downsides to this stuff is it takes like 20 minutes to make a single generation. And so I have this switcher built up here, which is like, if I'm just trying to find a good seed and just quickly test a parameter, I don't need to render every single frame at full resolution. So when I don't click this button, when it's turned to false, it does these settings. It's like 280p, 4 frames a second at 10 steps for just 2 seconds. So it will spit out like a video in like 1 minute. And then it's like, oh, these settings look good. This is a good seed. Then you turn it off. And now suddenly we're doing the full 720p, 16 frames a second for the full 5 seconds. And then, for the full steps. So that's just like a little tool that I've built inside of this workflow that makes this process a lot faster, because I think a lot of people spend so much time generating all these videos that don't get used at full resolution. But really, it's like you can really tune this stuff at low resolution when it looks like shit, and then just pick your favorite one and then run with that. This first column, all this stuff, this one, this one, this one, this one, this one, this one, this is all the models that get downloaded from the internet. So here's the Juan model. It's the 720p. There's LoRa's you can add into the pipeline. There's a text encoder that translates the written text into a language that the AI can understand. There's the photo that we're going to turn into a video. There's the clip vision that interprets the text. And this is all just stuff you download on the internet for free and you upload on your folder into into your computer folders. I'll post this all later, so if you guys are interested in looking at this workflow, it's going to be up and available, and links to all the download files so you guys can get this, but I won't go into all of it right now. The interesting thing about this model is, because it's Chinese, all of the training data, just like how we tricked the kid and told him to draw a blue banana, all the training data, it's not written blue banana in English, it's all written blue banana in Chinese. And so if you give it an English prompt, the text encoder has to do an extra step of translation in the background. And if you translate direct English to direct Chinese with Google Translate or with a basic translator, I don't know any Chinese, but I know that the languages are not anything in the same in how they're structured and how they work. And so much gets lost in translation when you go between the two languages. And so I also have a custom ChatGPT that is trained on Flux prompts and is trained on natural language Chinese and natural language English and the relationship between the two of them. And so then I can just, type my English prompt in and it gives me a translated Chinese prompt. And that basically helps you sing in the same language sing in the same harmony that the model was trained on. And the results are really a lot better if you use the Chinese natural language. And I'll also share like a link to the Chinese ChatGPT. But that was a big whatchamacallit. It really helped the images look better. And then there's like all the sampling settings and all this stuff. There's some nodes that make it run faster. This torch compile one. There's nodes that make it run on a worse computer. If you don't have a good computer, you can turn on block swapping. So there's all these optimization things you can do. And just like turning the models up and down, you kind of have to turn up, the CFG. What does it look like at 3 versus 4 versus 5? And what does it look like with the prompt like this or like this or like this? But eventually you land on a good image. And then you can just keep moving with different prompts. And so I'll just play a little reel of the stuff I created with this model pipeline. And so this is all the Flux images ran through WAN. And I did all the fine tuning of all the settings just with one image. And then once I found the good settings, then I, lock them all off. And then I just upload the images and then I keep running each image with a different setting. It's kind of like the same process of making images, but with videos. And yeah, thank you. And all of these workflows and the ChatGPT text encoders and the links to the downloads and the research and all the resources is going to be on my Patreon next week. It's all free. You don't have to pay for it. If you want to give me $5, you can, but you don't have to. So yeah, if you're interested in getting these resources and materials, that QR code should take you there. Thank you.
Thank you, Calvin. We have a little bit of time for Q&A, so I'll pass this mic around if anyone has questions for Calvin.
Thanks for sharing this, Calvin. I had a question about your captioning. I wanted to see if you could expand on it a little bit more and like if and how so you use trigger words at all. Like I mentioned, you talked about just like capturing the image as is, and also like combining multiple LoRa's. Like is if you're using trigger words, does each LoRa was it trained on the same trigger?
Yeah, that's something I should have mentioned. It's important when you have that data set of 30 images and all of your text files that you have one unique word that is present in all of those images. And it's important that that word is not a real word, because if it's a real word and your trigger word is painting, then suddenly as soon as you type painting, it's going to reference every image of a painting ever. So it's like I always use the @ and the $ and the exclamation point. So in your text file, you'll have the non-stylistic description of all the things you don't want to capture. And you'll also have, in all those text files, one unique word. And if you're stacking multiple LoRa's together, then when you're writing your prompt, you'll need to write all those trigger words. So every time you use one of those LoRa's in the pipeline, you'll want to use that trigger word in your prompt. The other thing that's interesting is you can actually train multiple concepts and multiple styles in one LoRa. So like if you have a body of work and some of it's black and white and some of it's color, you can make a unique tag for black and white and a unique tag for color. And then the model will understand in the training, like, oh, when he writes $!3, it should reference the black and white photos. And when he writes, 4447, you should reference the color photos. So a lot of people just train LoRa's with one trigger word to capture the general style, but you can also train models that recognize multiple trigger words, and it could be something as specific as a painting style, like the grain of the pencil that was used, or it can be something as abstract as something that isn't tangible that you think is unique to you. Like if 10 of those images just look super moody to you, then you can write a tag called super moody. And then when you type super moody, the model will look at those 10 images and it will make an image that looks like the average accumulation of those super moody photos, whatever that is.
Awesome. Thank you.
Hey, Calvin. Great work.
Thanks.
So is there a way to generate real-time content using ComfyUI? And if so, what does the pipeline or tech stack look like?
Yeah, there is. There's an awesome software called Daydream, which is from Eric's company, LivePure. And I don't have any on this drive. I don't have any of the pipelines, but it's basically the thing that's really critical in a real-time pipeline that generates images in real time is that the model is like what's called a quantized model, which is like a super compressed, super fast model. And then it uses a type of sampling called LCM sampling, which is like the super fastest sampling. And the trade-off to that is, the image is less fidelity. Like you're not going to get photorealistic looking things, but you can still get all these interesting and crazy styles. And as models get better and as compute gets better, eventually, hopefully, we will have, photorealistic things happening in real time. And there's a great one of the guys that works for Eric's company, this guy Ryan. He has a YouTube channel called Ryan on the Inside, and he has a lot of really nice workflow breakdowns for all the real time stuff. So I'd recommend checking his stuff out for sure.
Another one. Are you using your local GPU, or is there like a room full of hot GPUs somewhere out there?
I'm using RunPod, so this is like a 4090.
Oh, okay.
And I'm just paying by the hour. So this one is like 69 cents an hour. But often what I'll do is I'll rent like an A100 for like $1.70 an hour to do all of my like high iteration generation, and then like a slower machine when I need something just in the background, So RunPod's great because you can have a bunch of GPUs all deployed at the same time. I don't have a super great graphics card in this computer, and that's why I started getting into RunPod. And then I was like, oh, now I can have 10 graphics cards all going at the same time. So I use RunPod. I do not use my local machine.
But if you had a 4090 on your machine, you could.
Yeah, there's everything you do in RunPod you can do on a local machine. There's no difference.
Gotcha. All right.
And that's the beauty of it. It's like it's totally free, and all you need is a terminal window.
Thank you. That was a really amazing, informative talk. I was wondering if you had any insight into, or preference around reverse image captioning, or like your favorites for how you caption. I know you can, there's Florence, and then there's Lava, and there's different things. I'm wondering if you've kind of found any tricks or dark voodoo that would help.
Yeah, so there's a lot of tools that caption images automatically, but I think they oftentimes, like in the blue banana metaphor, they'll write the word blue. Like a lot of times they'll caption too specifically. And so I like using ChatGPT because I can instruct ChatGPT, because it's an LLM, I can talk with it and say how I want it to caption the images. So I'll tell ChatGPT, I'm training a model and I want to only write tags for things that I'm not trying to train for. So if I give you an image of a blue banana, don't write blue. I literally tell ChatGPT that. And then I feed it my images and it'll give me a bunch of tags. And then I rewrite all the tags by hand because usually half of them I don't agree with or I don't like.
I love how intense human is in the loop with your workflows, I gotta say.
How intense what?
The human stays in the loop.
Yeah. I think it's really important because if you let AI do its own thing, it all starts to look like AI. So you really have to give as much oversight as you can.
How do you do the bulk in chat? Are you literally throwing one image at a time and running it through like a pre-written system prompt to get your preferred?
I usually do like 5 images at a time. I think if you do 10, it starts being buggy. But honestly, a lot of times I just caption them by hand and I don't even use an LLM at all. So,
That's awesome. Thank you.
Yeah, you're welcome. Thank you for the question.
Hi. Thanks. Awesome work.
Thank you.
When you do the testing and then you run these iterations and you have hundreds of images, maybe this is just a shortcut or something, but how do you, in what program can you view all of these images?
I use PureRef, which lets you just drag and drop. It's a free program, and you can just dump as many images as you want into it. But sometimes I just go into the window viewer and just flip through. And it can be tempting to spend a lot of time looking at each image. But again, if you're looking at hundreds of images, a lot of times there's one or two that are a lot better than the others, and you don't need to spend a lot of time looking at them. Like you can just kind of like, if you have an idea of what you want, you can just flip through them really fast and be like, oh, that one's good. That one's not.
Yeah, but very often they just look very similar, like very, very similar.
Yeah, but sometimes the good ones are just like the good ones are just they're special, and you kind of know whenever you see it.
Yeah. No, you're right. But like then you also mentioned that you seem to have a very systematic progress, right? You start with your LoRa's and then you go to you start with your seed and then the LoRa's and then the prompt and then the guidance. But what I feel sometimes, like then I go back and change something in the very beginning and out of a sudden it's so much better. So I think it's still very like random in a way, right? It feels like you're trying to tame the beast, but then you change one little thing in the very beginning, it's all over and you're somewhere completely else.
Yeah, then the beast tames you.
All right.
It's not a rigid process. Like I also go back and forth and I also go and swap the LoRa strengths, and then that's like the general workflow I do, but it is a lot of luck and randomness. And so there's not a right way to do it. I think it's generally a good operation to start with the good seed and then to go with the LoRa and then to all those other settings at the end. But I go back as well,
Yeah. One more question.
Yeah, go for it. No problem.
You said you're using Flux.
Yeah.
Do you also use that because it doesn't have an Apache license, right? So if you ever do paid work, you can't use Flux.
If I take my paid work and then I export a PNG and the metadata is gone, like there's no trace of Flux in there. And the Apache license for Flux, if I understand it correctly, it's actually for the use of the Flux-based model itself. It's not for the outputs of it. So the Apache license with Flux means that I can't sell you a product. Like I can't have on my Patreon site and make people pay money for a Flux image generator that's just letting people use Flux. So it's interesting because the licensing for Flux, it's not for the outputs of the model, it's for the use of the model itself, if that makes sense. But also strip the metadata and protect yourself because those laws could change next year, and then, who knows?
Any other questions?
Thanks. Hey, Mike. Thanks again. It was a great presentation.
Thanks, man.
I recently got out of a long-term relationship with a 2080 Ti, so most of my experiences with Stable Diffusion. So I had a couple like Flux newbie questions.
Yeah, go for it.
I always found that when I added a bunch of LoRa's together and got much above a combined value of 2 for the weight, my images would start to burn. I noticed you had much higher, combined values. Have you found like a ballpark number where if you get above that, it starts to burn? And is that related to the Flux guidance, which I assume is like a CFG?
Yeah, it's... I find that there's usually there's usually in the LoRa pipeline like 2 LoRa's you can have at above strength 1.5. And then those are like the strongest ones. Like those ones will really set the style. And then you can probably have 5 more at a strength of like 0.5 to 1. And those will be like your less influential LoRa's. And then you'll have these like fine-tuned ones like I was talking about, that tattoo LoRa that makes the water look good. Like you can have LoRa's at a really low strength and you can have a lot of those together. So I think there's like 3 classifications of LoRa strength. There's like below 0.3, there's like 0.3 to 0.9, and then there's 1 to 2. And generally you can have maybe 2 or 3 of the strong ones, and then maybe 5 or 6 of the middle ones, and then like maybe 8 to 10 of the weak ones. But I think like, sometimes you just need 2 LoRa's. Sometimes you need 10. Like there's not really a standard. It just depends on the look you're going for. And sometimes that overcooking, like in this case, it helps to like really make the patterns super textured and super abstract. Like the overcooking can work in your favor also. And if you, with the flux guidance, it's a little bit like of a mysterious value. Like there's no written math formula about what it does. So you just have to test every single one. You just have to go through from 0 to 10 and look at all the different values and see what works best for whatever style you're trying to create.
And I assume for most of those, you're starting on low numbers, like maybe 1 or 2 LoRa, or maybe probably 1 LoRa at a time, a low CFG, and you're stepping it up. And then when you add a new LoRa, do you bring your flux guidance down a little bit and add the new LoRa? Is it?
No, I kind of just give priority to the LoRa pipeline, and then if it really looks like it's getting overcooked, you can bring the flux guidance down a lot.
Okay.
But the flux guidance is really sensitive. You don't have to change it that much. And usually if you're going for a realism, like between 1.5 and 3, it's somewhere in those numbers. If you're going for like a weird undercooked painting or sketch style like this, it might be under 1.5. If you're going for anime, it might be over 3. So there's like a couple ranges that you should be in, but I usually don't base my workflow off of that value. I usually just try to tune the model pipeline, and then I go and, once I have an aesthetic I like, then I decide how much cooking, quote unquote, it should have.
I got you. And you're kind of dialing in your steps and sampler early and then kind of.
Yeah, with Flux, I always use 35 steps with Flux. I find is like the sweet spot. But when I'm just trying to get a good seed or tuning the model pipelines, I'll run with like 20. And then once I'm like actually generating, then I'll just go back to 35.
Okay. And what sampler do you use? Just
I use, it's different. Like I do that huge grid and different samplers for different things. But I really found that for photorealistic work and for emulating like film grain and camera effects, that UniPC was a really good one. Because UniPC is like, it schedules the pixels individually, and so it emulates grain without like brushing over it and making it look like plasticky. And for, let's see what I used for this one. And for like more abstract and like illustrative work, I like DPM2 and DPM, like all the DPM stuff is nice. But sometimes you just have to do a huge grid and look at like 100 of them and see what works.
And you normally just keep the schedule, or you don't try like stochastic, or is it?
I usually do normal or simple, but in the grid, it's I run the combination of every schedule.
Oh, and the schedule
and sampler. Right. So I look at all of them, but normal usually works. Like I usually spend an hour running the grid of every single one, and I'm like, oh, normal looked great, and I just wasted 2 hours and $1.50 to look at all the shit that I'm not even using. So, the models are the most important thing, and the schedulers and the samplers and those guidance values, like those are all ancillary things that just affects the texture. But really, like the aesthetic control and the look and the taste comes from the model pipeline and the configuration of that.
Oh, thank you.
Yeah, thank you.
All right, one more question.
I'm curious what limitations you found with the WAN model in general.
A ton. It doesn't, like if you want something that's photorealistic and looks nice, like you have to use a closed source model, you have to use Kling. WAN is good for like weird anime and like interesting illustrative looks like this, where you're not going to make things super detailed and super rendered. There's a limitation on the length that you can do. Like once you go above 81 frames, you start to get degraded, and there's like hacks to get around it, but it's still like, if you want to do long clips, there's other options. The LoRa's aren't like as prominent as Flux LoRa's. The other thing I did in this workflow also is there's a LoRa inside of WAN that I trained on all of these select outputs. So I took like all my favorite outputs that I knew I was going to use in WAN, and then I trained a distilled LoRa on all of these outputs to help WAN stay inside of that style. WAN is really hard when you want a style that's not in its training, because it's pretty rigid. So like this was tricky because like you really need the Chinese prompts, you really need an added distilled model inside of the model pipeline. It also helps to have a negative reference image. So this is like this image here is this exact same image, just without the model pipeline. And this basically tells it basically tells Juan, make it look like this, don't make it look like this. And if those images are as similar as possible, that helps the model differentiate, this is the style we're not going for, and this is the style we are going for. It's also funny because you could rip an artist's style and you can put it in the negative style reference too. So it's like, people get so mad about, they're using my style in an AI pipeline, and I always want to use someone's style as a negative reference and be like, yeah, I used your style and told the model, don't make it look like your work, because you can do that too, because I don't like your stuff. So like you can use negative references to control the aesthetic. You can use LoRa's, you can use the Chinese prompts, but it's tricky to get stuff that looks as good. But I do think that, in the next year, there'll be an even better WAN model. And I think eventually the open source stuff will catch up to the closed source stuff. And it's just like a race to the bottom. Like, and then Kling will get better, and then WAN will get better, and then Kling will get better. So I'm hoping that when there's a better WAN model, I don't have to change any of this stuff, and I can just go in here and then add the different WAN model. Is the hope. But yeah, there's a lot of limitations. I don't think it has as many use cases as people say it does. The main bottleneck on all the video models is they only put 8-bit color out in Rec 709. And so like, if you're trying to use this stuff in a professional VFX pipeline, you have to have a whole nother post-production team to match the 8-bit footage to whatever the camera was shot on. Like, the camera's color space is so big, and it doesn't sound like the difference between 10-bit and 8-bit is a lot, but it's like millions of colors, and you really see it. And so not just WAN, but every single video model, including Kling, they all have a bottleneck with the dynamic range and the color depth, because it's very difficult to match it to real footage. Like, it might look really good in my AI reel where everything is AI, but as soon as you put it side by side with camera footage, like suddenly you need a whole nother team of people just to match the two footage together, if that makes sense. So that's not just WAN, but that's all the models. Good question.
All right, thank you so much, Calvin. Let's give it up.
Thanks. Thank you.
All right. Yeah, nice work. I'll just like take over. Yeah, go. You're sitting. Yeah. That was a super insightful presentation. All right. So I want to talk a little bit about our sort of thesis around using ComfyUI. And the core concept is something called generative production. So that to us means combining the existing workflows of 3D animation, 3D rendering, and integrating that into AI workflows so that we get the best of both. Traditionally, 3D animation work takes teams of artists, months of time, even to just create a single shot, right? So at ZeroSpace, we do client work with big brands and film directors, and the question is always around like, how do we make a project feasible? There's so many amazing ideas out there, but unfortunately, the resources it takes to create something can often be prohibitive, and that never ends up getting made. So yeah, just to recap, we're at ZeroSpace, we do tons of work with Unreal Engine. We're super bought into the idea of real-time 3D. So when Pixar first came around, you had Toy Story, and now like the evolution of 3D renders using like Octane, and these take tons and tons of machines, render farms, to generate a single frame. So with real-time 3D, the iteration speed becomes faster and faster. You essentially have a 3D workspace in which to create a scene, animate characters, add your particle effects. And as an artist, you get to see that work come to life much quicker. You don't have to wait for a render. And that's because these game engines were tuned for real-time gameplay, you know, like Fortnite or Gears of War or Call of Duty, these kinds of things. So here we've been working with 3D engines, and then we're seeing the power of generative AI tools for image and video generation. And we've been exploring ways to essentially take our 3D workspace, our interactive playground in which we can create scenes and worlds, and then use AI models to restyle, reframe, to improve fidelity, to make something that looks one way, you know, maybe like a typical Unreal Engine game scene with they kind of a certain look, into something that might feel more organic or more painterly or whatever it is that we're going for. And that often takes, you know, if we were to try to do that in the engine itself, you're kind of fighting an uphill battle, right? The engine is tuned to kind of look a certain way and render things a certain way. So if you want to go like a, you know, like a grease pen look or an illustrated look, you're really tuning every material and every object in your world to try to match that. So this would be tons and tons of work. So, you know, we see these AI models as like a post process that can take one thing and then transform it into something else. We obviously explore proprietary tools as well. And the real pain point is that you end up doing something like prompt roulette. The AI models that are hosted in the cloud and served up by companies like Kling and Runway and VO and all these, they have very limited control over what you get, right? So if you try something, if you have an idea and you paste in your prompt and you get something back, if you want to make a change, it's really hard to do like a fine-tuned edit. You know, there's just not a lot of parameters you can change to get what you want. So what you end up doing is trying something, and then like it gives you something that maybe is closer to what you want, but not quite, or maybe something completely different. And you end up running dozens or even hundreds of generations, and to a creative, this process is kind of stifling. It's quite frustrating as an artist to kind of butt your head against the wall of reprompting and reprompting. So in our explorations of open source, by nature, there's more control. Like you have the model running on your own computer, and there's so many different nodes you can use to modify, extend, control these outputs. I mean, you saw the work that Calvin did and the LoRa stacking, tuning the sampler, all these things. So I want to talk a little bit today about an internal project we have here called Night Fight. This is a project that our mocap director, Sammy, came up with. He is a trained actor and choreographer, and basically designed this fight choreography. And we thought it would be a perfect test of what open source video generation is capable of. If you try to use something like Kling or VO, I mean, you'll get realistic motion, but the scope of what you can explore is limited, right? When you start having complex, choreography, things like fight scenes, there's a lot of interaction between the characters. People are passing in front of each other. There's fine details like, the way the elbow is located and moves through space throughout, a given sequence. So these models often struggle with this kind of output. And at ZeroSpace, we have a motion capture studio, and we can get perfect ground truth level data around how characters are moving. So if we can somehow connect these traditional workflows of like, okay, here's animation data captured on set with two performers, and feed that into the video models and tell them to listen to this choreography we had, all of a sudden we can explore any kind of human movement. And that to us is super exciting. So the log line for Night Fight is two knights who are once childhood friends meet beneath the ancient tree where they used to play, fulfilling a destiny that transforms their wooden swords into steel. So Sammy recorded mocap for this short film a while back, last year. And we've kind of been sitting on it and figuring out what's a good time to actually make this into a production. And when the WAN video models came out in the last few months, we suddenly saw a step change in the quality that was possible with open source. And we felt that now was the right time to really dive in and try to figure out these workflows. So what you see here is what we call a gray box. In game design, this is when you're first blocking out your level. So you have basic geometry. You're not really putting in the time to get to like the final texture, the final look, the final lighting. If you see these characters are kind of like these basic, like, this is kind of what comes out of the motion capture system. It's like a generic human form, right? And the question is like, can AI take this and then a bunch of guidance around how these characters move in terms of their skeletal poses, as well as what kind of look we're trying to achieve, and get to a result that, you know, in 10 minutes could take a typical artist like weeks of work or even months. So to break down all the underlying layers is quite fascinating. This is kind of the power of using a 3D game engine, right? So on the top left, you see the pose data animated out of the engine. So these are basically like the movements stripped down to their bare bones, like literally. These are the individual skeletal joints and bones that compose the animation. And when you're using a motion capture system, this is like the very essence of what you're getting, right? It's solving for these joint positions in 3D space and then just drawing lines in between. On the top right, what you see is a depth map. So a depth map is basically a representation of your scene where things that are close to the camera are lighter colored, and then as you fade into the background, it gets darker. So this is a way for the model to understand like the spatial positioning of different objects in your scene, and this makes a huge difference in the quality of your output. On the lower left, this is an edge detection. So it's essentially finding the outlines of the objects in your scene and creating a video that just shows the outlines. And you know, one common trope of using AI generation is that like lines and details can get fuzzy, or like you have that kind of AI slop feeling where, you know, maybe the fingers kind of mush together, or like details kind of warp and shift over time. So this kind of detail pass helps model understand these are the defined contours of the objects, and please respect them. And then on the bottom right, this is an unlit pass. We actually didn't use this in our workflow, but I thought it'd be interesting to show anyways. You can essentially block out and assign colors to different objects in your scene. So this will help the model understand, like, say, for example, you wanted to prompt just the blue character with a certain look, and then just the pink character with another look. And you can apply like a LoRa to each one and have it treat them in separate passes. So after our workflow, which we will get into in a moment, these are the results, right? So the top left is what you just saw. This is our gray box. And then the rest of the three images are applying different styles to that basic, you know, gray box plus the depth data, plus the animation data, plus the edge data, plus whatever else you might want to put in. So the top right and the bottom left are sort of the illustrated knights fighting, you know, like in medieval times sort of vibe. And then the bottom right is just kind of a fun experiment. Like, let's make this look cyberpunk, futuristic. They're in some kind of, you know, like virtual world, and there's a representation of data, you know, kind of embedded throughout the scene. It's just kind of fun. I was inspired a little bit by Tron, and you see like how much it respects the sword fighting. I mean, even we tried using some commercial models that do video to video, like Luma's new modify video feature, and it couldn't really get anywhere close to this level of motion fidelity. So this to us is super exciting, and it's actually quite a new result for us. Like we've been just this week able to get this result. So we're super excited, and this to us proves our hypothesis that with open source and the right kind of control and guidance, you can get better results than commercial models, which is great because I think that creativity should be democratized. So let's get into the workflow a little bit, unless there's any questions about this first that people might have. And then we can walk through kind of how this works, how we thought about connecting the nodes together, what exactly our inputs and outputs were. Yeah, unfortunately, I don't have a microphone to give you, but just, yeah.
Did you use a reference image for different looks, or was that a LoRa? What was that to get?
Yeah. We used a reference image, which I can pull up in a second once we remote into first frame. Yeah. We are currently exploring LoRa's as well. So getting a LoRa trained on let's say 50 images of the illustration style we're going for. We're using a variant of WAN called VACE or VACE. Don't know how you pronounce this, but it's quite new. So there's not as much of a LoRa training infrastructure around it yet. And we're kind of trying to develop that as we speak. Yeah. So I'm going to invite Jason up to the stage, and then we're going to remote into the computer. It's a workstation upstairs that we're using to run these generations and walk you through the workflows and such. Yeah, so I'll give this to you.
Fun time.
Yeah, I'll have him bring the other mic over. This is the demo Gremlin strikes again. Okay. My computer's like freaking out. That. Can we get the other mic as well?
Why don't you start us off while I figure out where we're at?
Yeah. So this is our Comfy workflow. A lot of the work that we did over the past few weeks was trying to optimize for generation speed and quality. So you can download the WAN base model and just start playing with it. But then there's tons of these very technical optimizations that the community has come up with. But you do not have to be technical to use the optimizations. Fortunately, they've been packaged up into Comfy nodes, and as long as you know how to connect them together, you can cut down your generation time by half or more, and then also improve the quality, which is kind of ironic. It kind of doesn't make sense, right? You can get faster generations but higher quality, and we're still trying to figure out what exactly is happening under the hood. But it just goes to show the WAN base model could have gone to a certain level, right? And maybe one could say that is inferior to the commercial models. But then the community has just come up with all these amazing improvements. And now, as you've seen, we've in some ways been able to surpass the commercial models.
How's it looking?
Got to get pretty close.
Yeah, I know. I realize.
Yeah.
I can tell the difference between. Oh, that's gonna be fun. I don't know what the overall experience with Comfy in this crowd is. It tends to be pretty good, but whether you're a beginner or have been doing this for a while, you might notice this is a really, really simple workflow, like very little going on at all. Just to spare your eyes, we hid the connectors. It is a absolute spaghetti mess behind the scenes. But when we started this off, like, a little less than a week ago, the key thing was that to do a multi-GPU setup like this, it turns out certain nodes don't exist yet for Vase. So we coded them up overnight. This one specifically here for all of the control net preprocessors was really helpful because without the ability to set CUDA to a specific graphics card, it just would not work. And this one right here, we're not really sure it's exactly working perfectly right now. We're actually running a test right now because I finished this one up maybe a few minutes ago. But it's all very, very much real time and in production. We are probably also getting feedback from the mics being so close. Let's see. How about this? Why don't we just ask the crowd, what parts of this like massively complex workflow would you like me to zoom in on most? I can't really see anybody out there. What's that? Inputs and outputs. Sure. Yeah, that sounds great. Yeah, that sounds great. Well, actually, so I'll take one step earlier than that and show that the overall pattern we're following here is making it so that it's really easy for mixed creative production teams with all kinds of different talent and styles of work to be able to choose their path for how they want to go about it. So depending on whether or not you're doing, for the control maps especially, whether you're doing just raw from a reference video generation in the workflow of various control maps, or if you're doing the pre-made control maps out of Unreal or wherever else, you can just, oh, that's kind of weird. We actually have them both set right now. That would make a lot of sense. You can just choose which path you want to take. Like any other workflow for WAN or Vase or pretty much anything ComfyUI, we have our positive and negative text embeddings, right? We have some selectors here that are hooked up to a bunch of the other nodes to choose your size, your steps, duration, CFG. We have a lot of optimization going on here. But for the reference video, you just go ahead and load it up right here. That's where we have the gray box for this workflow test, at least. And you have your style reference first frame image right there. And it's taking a lot of information from this and basically from the control maps. Let's see. For the models, for right now, so this is running on a 3X A6000 machine. So we played around a bunch with the FP16, but that's a 33 gig Vase model. And just to give us a little bit more breathing room, we bumped it down to the Q8 quant. Have that and the VE. It's really important to have those running on the same card, otherwise it just freaks out, doesn't work. But for those, we have it on CUDA 1, and for the clip, it's on CUDA 2. And then pretty much everything else by default runs on the first graphics card. We can take a look at the K-sampler right here. It's kind of like, it didn't work.
Is it significantly slower if you run the clip on, say, the processor with GPU?
Sorry, what's the last part of that?
Instead of the GPU, what if you ran the clip?
Oh yeah, no, it would be significantly slower. Yes.
It's much slower.
Yes, it's much slower if you're running any of this on the CPU. Really, yeah. There's very there's like one or two things that I think are running on CPU. I don't remember off the top of my head what those are, but no, definitely the clip. It's important. Yeah, it's important to have that on the GPU for sure, especially because we're running it at a reasonably large enough quant size. Like we're doing the clip at F16, FP16, and that's a pretty large file itself. So for this overall, here, I'll just go ahead and, well, let's see if I can actually see it. I'll do that. And take a look at what's running in here. So we've got, this is taking about 8 minutes, which is a little bit longer than what most of the ones we've been running recently are going for. But to get a full 5-second output clip, we've been seeing more like 6 minutes on the regular for these runs, with all of the different inputs going on. That's been pretty impressive because at the start, it was more like 25 minutes, like a few days ago. So I'm pretty happy with that improvement.
And you're using all of these control nets at once, right?
Yeah. Yeah. And we have toggles and stuff.
Yeah, sometimes we have, for example, when you have like the starting frame as like knights, and then your gray box is like these like little sort of Vicon character, like these like basic human forms, and there's not really much of a match. You want to be careful about what control nets you apply, because they're very, very influential on the output. They're essentially conditioning the video outputs, right? So if you have, this right there is your depth control net, your final form, like the humans in that video are going to look similar in like size and shape to what you have in your depth. So in that scenario, maybe you're just using pose, for example.
You said you had a custom control and pre-process.
Yeah, wrappers. Specifically, we created wrappers because multi-GPU, which is what we're relying on for most of this, doesn't support preprocessors yet. There's no node for it. And after scouring everywhere, there were no nodes for it anywhere. So we created wrappers for that. And I just created a wrapper for the VHS node also for the loading of the pre-made maps. And that seems to be working pretty well, considering that I just finished it literally minutes ago. So,
Are you going to put that on GitHub, or is it just?
I mean, the wrappers are on GitHub right now.
Yeah, they're on GitHub right now.
Yeah, totally. But I'm sure we can put that up somewhere later on so people can access that. We got something outputting right there. There we go. And that's the output that was just made while we were sitting here. Let me zoom in on that as much as possible.
So that's kind of like a fun little lightsaber duel, maybe like 2 Padawans. And what we see is sort of the next step is we're able to generate like 3 to 5 second videos that are quite compelling. But we still are working on getting consistent generations from shot to shot, right? If you're a filmmaker, your scene is broken down. You have the wide, the close-ups, whatever. Getting a consistent character look, getting a consistent style for the environment across all these different shots is our next step in this process. And then beyond that, letting AI help us orchestrate all these different shots, creating image styles like first frame styles, creating the text prompts that describe the motion inside the input video. All these things I think can be automated and then orchestrated to make it so that, I'm not copy pasting like text from, ChatGPT into this like text encoder and, shuffling images around on my hard drive and that kind of thing.
Yeah, the orchestration piece is really huge. The orchestration piece is really huge. Oh, I thought you were going to ask a question. Yeah, no, it's really tricky for me. I was saying the orchestration piece is really huge. That's going to just solve so many nightmares. There's so many little menial tasks that creative teams have to put up with. I don't have to tell you all, I'm sure you know. But just seeing, I don't know how many of you have tried Claude Code, for example. The amount of just sort of natural flow that it can induce if you just sort of get into a rhythm and prompt it correctly ahead of time, prime it. And like translating that to where we have multi-agent orchestration, especially when you have the luck, I guess, of having access to multiple machines that you can like split up different tasks on. Just imagine having a ComfyUI instance on 3 different machines, and then like a DeepSeek or some other strong local model on another one, actively helping you to cut out all the wasteful work that you wish you weren't doing, so you can actually be creative instead. I am very impatient about that happening as soon as possible.
We'll just continue taking questions. Okay. Yeah, I think that's it. Thank you so much for. Oh, yeah.
You do not need to have a mocap studio. No, definitely not.
Like the other, like the auto visual net generation, like using, PoseNet and like basically you can toggle between our ground truth control nets and then they can actually generate them for you.
Yeah. Okay. Cool. I'll totally do that.
I turn up on mic so you can.
Yeah. Cool. I'll do that. Why is that not working? Yeah. Are we still connected? These are the wonders of using remote computers to handle this kind of stuff. Well, it would be really nice to show it all, but since that's not responding right now, what that little selector does is if I can hit the no at the top and turn it to yes and switch off the one below it, it'll take from our raw video input, the reference video that we have right here, and instead of following all the pre-made Unreal maps down here, it will generate them on the fly, right, from whatever inputs you have. So for example, if you have a bunch of mocap footage from your phone or whatever, any source, doesn't matter, you could be using that, or you could just take a initial source video and generate it all directly in the workflow. The key bottleneck, which I think is just a bottleneck industry-wide, is getting access to enough VRAM that you can run something like this on, right? So like, if it was a single RTX Pro 6000 with 96 gigabytes of VRAM, then this whole thing could probably run on just that, right? But that's, 10 grand a pop. So most people don't have access to that. We did earlier today, Derek here was running this workflow on a two 6000 ADA machines. So that was 48 gigabytes each, and that was running. So that's great. It's a little bit more doable. And with RunPod or anything else of the sort, you can totally get like a 2x card. It doesn't break the bank. Not as democratized as it should be, but it's still doable.
I guess you could. Hello? Okay. One could just record an iPhone video of your friends, like doing whatever, right? And you could just generate. There's pose detection models that can do the animation step for you if you don't have access to a mocap stage like this one. It can also generate the edge map and the depth map and kind of provide you with all of these controls over your generations. And it might not be as good as what we're able to accomplish, but like there's certain quality standards that like we have to hold ourselves to, and as individual creators, at home, like I don't have any of this stuff, right? So we can all just mess around and just create stuff and have fun with it.
One thing, maybe tonight after the bar, I don't know, or maybe tomorrow, that it will be a lot of fun to test out. A lot of this we were still tweaking up until literally the last minute because it hasn't been that long, and there's a lot going on under the hood. But we haven't gotten around to some of the more exciting things I think that could be done with it. It's going to be very interesting, for example, to take footage from, say, Daydream. Like I have some footage from the last ComfyUI meetup a month ago that it'll be a lot of fun to put that in and use that as the sort of source truth to see just what we can do with that.
Hey, this is really cool. I've never used ComfyUI before, but I've been using a lot of Touch Designer at work. And so I was noticing all of the note taking and other things that you're using kind of to narrate the process. And you mentioned that you hid the spaghetti, so to speak. I have a couple patches from vendors that look like spider webs. And I was wondering what you guys do as a team to, like, especially developing open source documentation, like what kind of standards do you use in a team, and like when you're producing it for something that goes on GitHub is supposed to be used by other people, what do you follow as a group?
Yeah, I think that's a great question. I also use Touch Designer, and I find that Touch Designer has a lot more tooling around like organizing your nodes. Like there's, you can collapse graphs into functions, have your reusability. That kind of stuff is just making its way into Comfy. So we're all figuring it out. And right now it's a little bit of a nightmare. Like if you turn on the actual node connectors, you'll kind of see how hard it is sometimes to follow like the inputs. So it's an open problem. Like it's challenging, and different people have different ways of connecting their nodes together, or like different ideas around how things should be laid out. Like you're essentially creating UIs every time you use Comfy. Like you're creating your own little like customized UI, and you can either, you know, try to abstract things away and have all your settings like on the left and have it be super neat, or you can kind of be in there, you know, in the weeds of it, like messing around and like hopping from node to node. So yeah, I guess there's no easy answer. I think probably within the next 12 months, there's going to be a lot more quality of life improvements around using Comfy. Them as a team, I think, are very actively working on this. And also there's probably going to be a lot of open source community efforts to, you know, just people feeling the pain and wanting to solve that. I have no idea how this would work, but like an auto node formatter would be pretty sick. Like you just press a shortcut and just auto formats, just like you auto format your code. There are auto formatters, for example, in Unreal Engine Blueprints. It's like a node-based visual scripting system. Sometimes it works great. Sometimes it just makes an absolute mess of what you had before. So yeah, hitting some kind of balance is also going to be important.
Yeah, so now you can see it's a very, very simple workflow. There's just no lines here at all. And if we were to unpack any of this, like a lot of stuff is, well, it's still not responding to me, but anyway, take my word for it. A lot of stuff is collapsed right now, and it's really made to allow for creative talent to be able to navigate their way around the interface, more so than what's going on under the hood, because there's a lot of abstraction going on in terms of where things are oriented, where things are placed, and how to connect up all the different nodes.
I think subgraphs are actually coming to ComfyUI like really soon.
Yeah, they are.
So that'll be a big one. And it's not just like collapsing a bunch of nodes into like, you know, one node and then going into it. It's actually setting up ways to copy that and like retaining the changes, right? So every single instance of that little subgraph, when you make a change to one, it makes a change to all of them. And that's actually new. And that's the concept of like a function, you know, in programming. So getting that will definitely help us build abstraction so that what you see here doesn't always have to be everything like thrown at the wall. All right, well, we'll be around to take more questions afterwards. But yeah, thank you so much for coming and for listening to our presentation, asking all these great questions.
All right, thanks everyone. I think we'll hang out here for a little longer, and please go eat the pizza and the snacks. If you want to join us, we'll head out to Three's Brewing, which is down the street, in about like 15, 20 minutes. Yeah, we can continue chatting. Thank you all for being here. And thank you, ZeroSpace, for hosting. Thank you.